So now we see the another problem based on photoelectric effect. So in this problem, so it's given that when an electromagnetic radiation of wavelength 300 nanometer, the positive light on the metal surface is 300 nanometer, it falls on the surface of a sodium. Electrons are emitted with a kinetic energy of 1.68 into 10 to the power of 5 joules per mole. Here the kinetic energy is given per mole of electrons, not for one electron. It is given 1.68 into 10 to the power of 5 joules per mole. So we need to find what is the minimum energy need to remove an electron from sodium. So this is the first problem. Okay. So we need to calculate the minimum energy need to remove an electron from sodium. So first we see about the energy of the electromagnetic radiation passed on the sodium. Okay, we know that so this is the sodium metal, a radiation is passed on it. So electrons are ejected. The electrons are having this much of kinetic energy. So first we need to calculate. So what is that energy of this positive light? So ఇక్కడ పంపించిన light energy ఎంతో find out చేద్దాం. సో పంపించిన electromagnetic radiation కి మనకు wave length ఇచ్చిండు. సో wave length ఇచ్చినప్పుడు how to energy equals h nu, that is hc by lambda. H 34 see ఇక్కడ joules into second use చేసాం కాబట్టి use SI method means meters per second. So what is the lambda? 300 nanometers. So the energy, finally the energy of that electromagnetic radiation passed on the sodium metal is, we can write see become minus 7, this becomes plus 7. This two will cancel here, becomes plus 7. So the energy here become 6.625 into 10 to the power of minus 19 joules. So we know always the E is equal to h nu formula is always for one particle. So this is for one photon of this light. మనం పంపించిన electromagnetic radiation sodium metal పై పంపించిన electromagnetic radiation wavelength ఇచ్చిండు. సో దాని ఎనర్జీ ఈక్వల్ h nu తో క్యాలిక్యులేట్ చేస్తాం. సో వాట్ ఈస్ దిస్? ద ఎనర్జీ ఈక్వల్ h nu ఆల్వేస్ యూజ్డ్ ఫర్ వన్ పార్టికల్. అంటే ఆ లైట్ లో ఉన్న వన్ ఫోటాన్ ఎనర్జీ ఇంత. అయితే ఇక్కడ మన kinetic ఎనర్జీతో కంపేర్ చేయాలి. వాట్ ఈస్ ద మినిమం ఎనర్జీ రిక్వైర్డ్ టు రిమూవ్ ద ఎలక్ట్రాన్ ఫ్రమ్ సోడియం. ఒక సోడియం ఆటం నుంచి ఎలక్ట్రాన్ తీసడానికి ఎంత ఎనర్జీ అవసరం ఫైండ్ అవుట్ చేయాలి మనం. ఇక్కడ మనం పంపించిన లైట్ ఎనర్జీ తెలుసు, బయటకు వచ్చిన kinetic energy of electrons తెలుసు. But the kinetic energy of electrons given in joules per mole. But here we calculated that is energy joules per photon. That is one photon energy. But in 1 mole kinetic energy of electron to compare cheyalante, the energy of this electromagnetic radiation is also must be in joules per mole. 1 mole of photons ki calculate చేయాలి. So this is the energy for one photon. Therefore energy of 1 mole of photons. So we know that the energy of one photon this much. So what will be the 1 mole of photons energy? This is for energy of one photon. For 1 mole we need to write the 1 mole, and here it put 6 point, here approximately we get so this is the energy of 1 mole of photons of light passed on the sodium metal. ఇప్పుడు సోడియం మెటల్ పైకి ఈ సోడియం మెటల్ పైకి పంపించిన లైట్ ఎనర్జీ ఎంత అంటే 3.9 into 10⁵ joules per mole. సో ఇప్పుడు రిలీజ్ ఎలక్ట్రాన్స్ రిలీజ్ అవుతాయి. సో వాట్ ఇస్ ద కైనెటిక్ ఎనర్జీ ఆఫ్ ఎలక్ట్రాన్స్? ఆర్ ఇట్ ఈస్ గివెన్ 1.68 into 10⁵ joules per mole. యాక్చువల్ మనం ఇక్కడ డైరెక్ట్గా చేయొచ్చు క్యాలిక్యులేషన్, బట్ ద కైనెటిక్ ఎనర్జీ గివెన్ ఇన్ టర్మ్స్ ఆఫ్ మోల్స్, జౌల్స్ పర్ మోల్. కాబట్టి దీన్ని కూడా జౌల్స్ పర్ మోల్, ఇక్కడ మనం పర్ ఫోటాన్ వచ్చింది, ఇక్కడ పర్ మోల్ ఫోటాన్స్. ఓకే, ఇక్కడ జౌల్స్ పర్ మోల్ ఫోటాన్స్ అంటే ఇక్కడ 1 మోల్ ఫోటాన్కి ఇంత ఎనర్జీ రిక్వైర్డ్. ఓకే, so we know the formula, that is h nu is equal to h nu naught is the kinetic energy. So we need to find the minimum energy need to remove an electron. The minimum energy is nothing but what? H nu naught. So we need to calculate this h nu naught here. So that is h nu naught is equal to h nu minus kinetic energy. H nu you got minus. So what is the kinetic energy of electrons per mole? Is given 1.68 into 10⁵ joules per mole. Okay. So on this calculation here we get therefore h nu not equal to the by 10⁵. Here it is approximately 2.31 into 10⁵ joules per mole. So this is also we got in terms of mole. So but in the final question is the minimum energy need to remove an electron. An electron ki find out cheyalem. So but here total the problem is per mole it is calculated. So again we need to calculate it for 1 electron. Okay, 1 electron remove cheyani calculate cheyali. So this is for 1 mole of electron ki manam calculate chesam ikkada. So already ikkada 1 photon calculate chesi again we converted into 1 mole because kinetic energy given in terms of mole. Kinetic energy moles లో ఇచ్చింది కాబట్టి యాక్చువల్లీ ఇక్కడ 1 ఫోటాన్ కి ఇచ్చింది కాబట్టి డైరెక్ట్ గా 1 ఎలక్ట్రాన్ చేయొచ్చు. కానీ కైనెటిక్ ఎనర్జీ మోల్స్ లో ఉంది కాబట్టి ఈ 1 ఫోటాన్ జౌల్స్ ఆఫ్ ఎనర్జీ మనం మోల్స్ లో కన్వర్ట్ చేస్తాం. ఆ మోల్స్ లో కన్వర్ట్ చేసి 1 మోల్ ఆఫ్ ఎలక్ట్రాన్ రిమూవ్ చేయడానికి హౌ మచ్ ఎనర్జీ రిక్వైర్డ్ ఫైండ్ అవుట్ చేస్తాం. బట్ ద ప్రాబ్లమ్ ఇట్ ఈస్ గివెన్ దట్ రిమూవ్ అన్ ఎలక్ట్రాన్ ఫ్రమ్ సోడియం. సో మళ్ళీ ఈ మోల్స్ ఆఫ్ 1 మోల్ ఆఫ్ ఎలక్ట్రాన్స్ రిమూవ్ చేయడానికి యూజ్ అయిన ఎనర్జీ నుంచి మనం 1 ఎలక్ట్రాన్ కి ఫైండ్ అవుట్ చేయాలి. See, to To remove 1 mole of electrons, energy need to remove 1 mole of electron is 2.31 into 10 to the power of 5 joules. Then what about remove an electron? So what is for 1 electron it is how much? Okay. This is 1 mole of electron. 1 mole of electrons means that is for 6.023 into 6.02. This is Avogadro number. 6.023 into 10 power 23 electrons require 2.31 into 10 to the power of 5 joules. Then what about 1 electron? So that is equal to and finally we will get we can written as minus 19 joules per 1 electron. So this is energy required. This is the answer for first problem. Here the two questions are given. So what is the minimum energy need to remove an electron from the sodium? So we calculated energy required for removal of 1 mole of electron, and then we got the energy required to remove 1 electron from sodium atom. Okay, this is the first answer. Okay. Next in this problem, again it is asked that find the maximum lambda that will cause a photoelectron to be emitted. In the same, here we calculated the amount of energy to remove an electron, but this is in terms of energy. This energy ni manaku em endulo find out cheyamannadu, find out in terms of wavelength. Same here, the minimum energy. This is the maximum lambda that will that will cause a photoelectron, means that is used to remove an electron. Okay, see, in the second calculation, we need to find the lambda. So lambda value find out cheyali. So for what? For photoelectron to be emitted, photoelectron ikkada emit avvadaniki, so what is the energy required? So the energy required is, we know that we need to convert it into lambda. So for one particle we know that equal to hc lambda, we need to calculate lambda e. So that is equal to what is energy? On this calculation, here we get as we use the total SI units, we get in meters. So the finally that is 517 place of this we can write nanometers. Okay, means lambda is equal to 517 nanometers. Okay, this is the maximum lambda, maximum wavelength that must be used to make photoelectron to be emitted and photoelectric effect and electron eject అవ్వడానికి అక్కడ యూజ్ చేయాల్సిన lambda. So this is exactly we calculated with the help of this energy. Okay, just take it and practice for 2 or 3 times for this type of problems. Okay, see the next one related to the photoelectric effect. So it is somewhat different to the earlier problems. So it is totally different compared to the earlier one. So here a certain metal was irradiated with a light of frequency 4 into 10 power 16 second inverse. The photoelectrons means the ejected electrons had 3 times to the kinetic energy as the kinetic energy of photoelectrons emitted when the metal was irradiated with a light of frequency 2 into 10 power 16 second inverse. And here using metal is same. The same metal is used for the photoelectric effect for 2 times. Given that at first the metal was irradiated with a frequency of 2 into 10 power 16 second inverse. And the first 2 into 10 power 16 second inverse frequency ఉన్న light metal పైన పంపిస్తే release అయ్యే electrons kinetic energy. Next in the second time the metal was irradiated with a light of frequency 4 into 10 power 16 second inverse. So ఈ second time వచ్చిన eject అయిన electrons kinetic energy ఎంత ఉందంటే ఫస్ట్ టైం అంటే 2 into 10 power 16 frequency లో లైట్ యూజ్ చేసినప్పుడు వచ్చిన electrons తో కంపేర్ చేస్తే the kinetic energy of electrons released when the frequency of light 4 into 10 power 16 is usually 3 times to that of this experiment. Means we know the general formula, that is h nu is equal to h nu naught plus kinetic energy. Here there is no change in the h nu naught because the metal is the same. Same metal is used for 2 times experiment. This is first experiment or this is second experiment. 2 times same metal is used. That's why there is no change in the h nu naught. There is information given about the kinetic energy of these electrons released. Here the frequency of experiments 2 times is given. So we can write here comparison information is given, kinetic energy. So we know the relation kinetic energy equal, we will get h nu minus h nu naught. So K is equal to h nu minus nu naught. So for 2 times experiment kinetic energy of first one, we can h is a constant, nu 1 minus nu naught. There is no change in the nu naught. So this is the critical frequency. Critical frequency means nothing but threshold frequency, the minimum frequency of light used on metal to eject the electrons and photoelectric effect అవ్వడానికి, అంటే photoelectrons release అవ్వడానికి యూజ్ చేయాల్సిన minimum frequency of that light is called critical frequency, nothing but threshold frequency, nu naught. ఈ nu naught ఒక metal కి specific, the fixed value. So అది మనం find out చేయాలి. So it is equation 1. And the second time experiment, second there is used another frequency, that is nu 2 minus nu naught. So by doing equation 2 by equation 1, nu 2 minus nu naught by h into mu naught. Get. And we know that Ke2 by Ke1. Ke2 by Ke1 means the second time kinetic energy is 3 times to the first one. So that is equal to 3 by 1 nu 2 minus nu naught by nu 1 minus nu naught. On cross multiplication we get 3 nu 1 3. What is the new one value? This is for experiment first one. So what is the new 2? Well, 3 nu naught, 2 nu naught is 2. Here 6 and 4 we will get 16 equal to 2 nu naught. Cancel. So finally you got threshold frequency, the critical frequency is 10 power 16. So here my important in this formula is the kinetic energy of electrons are compared here using same metal. The kinetic energy of electrons in two experiments is different because in two times they use different types of radiation. In the first experiment, they posted the light frequency of 2 into 10 power 16 second inverse. So, appudu kinetic energy of electrons second time 4 into 10 power 16 second inverse చేసినప్పుడు వచ్చేదానికి comparison ఎలా ఉందంటే second time చేసింది 3 times greater than the first one. Okay, so that is used in this equation. With general equation, we got the equation for kinetic energy for first time, kinetic energy second time for the electrons, and by making ratio we will get Ke2 by Ke1. We know the given value as 3. So finally we got the threshold frequency, nothing but critical frequency. The minimum frequency of light used to remove the nothing but to eject the electron from a metal is 10 power 16. It's a specific for a metal. Okay, take it. So practice this type of problems for at least 3 times. Here, so here and another important model. So an electron beam can undergo diffraction by crystals. Means the crystal diffracted with electron beams. We need to find through what potential should a beam of electrons be accelerated so that its wavelength becomes 1.54 angstroms. 1.54 angstroms. So here we know the formula that half mv square is equals electron volt. Okay. And we also know that lambda is equal to h by mv. Okay, this is the formula which will becomes in a de Broglie's equation. So we substitute in equation 1. Here we will get v is equal to h by m lambda. Substitute, say it is equation 2. Substitute this equation 2 in equation 1, and here we get half m. V square means h by m lambda square, that is electron volt, half m, that h square by m square lambda square equal to ev. So the h value we know, square. So what is the, here the m is there. So what is the mass? The total, we are passing the electrons. We know the electron mass, the 2 is there. So what is the lambda? 1.54 angstroms. Angstroms means converted into meters. Lambda square means again 1.54 into 10 to the power of minus 10. So this electron is the charge of electron, this is the potential. So by doing this electron here, E, and you know the charge of that electron, 1.602 into 10 to the power of minus 19 coulombs. Okay. Here finally we will get 6.625. So here we approximately get 10 power, this is minus 68. By here so this is minus 31, 41, 51, 60, 70. This becomes 10 power minus 70. So across here we get so that is exactly equal to 63.4. So here we get 0.634 volt. So nothing but 63 volts. So this is the potential required that electrons be accelerated to this potential so that its wavelength becomes 1.54 angstroms. Okay, this is totally, there is just one or two problems are there of this type. Just remember these two formulas separately. Okay. So here it is exactly the problem is similar to the second problem. So try this model. Okay. Take the problem and do it in your notes. ఓకే, కంపల్సరీ మనకి మళ్ళీ చెక్ చేస్తాం నోట్స్ కాబట్టి కంపల్సరీగా ప్రాబ్లమ్స్ ఆల్రెడీ దీంట్లో ఉన్న విత్ సొల్యూషన్స్ అండ్ గివెన్ హోంవర్క్ ప్రాబ్లమ్స్ యూ మస్ట్ డూ ఇట్.